So the main part of this section is the rational zero theorem. And before calculators, this was the best way to find solutions to higher power polynomials. So degree 3 polynomials, degree 4 polynomials. There are cubic formulas and quartic formulas, just like there's a quadratic formula, but those are a lot harder to use. So this is actually the best way to find solutions to higher degree polynomials, because factor by grouping doesn't always work, and again the cubic and quartic formulas can be quite difficult. So this was actually the best way. That doesn't mean that this doesn't take a little bit of time, which it does, but after some practice it kind of gets a little bit better. So the p's, these are going to be the factors of the last term. The q's, these are the factors of the leading term. And then if we take p over q and really come up with all the different combinations of those fractions, those are the candidates for the rational zeros or rational solutions. So it says find all real zeros of the polynomial and write the polynomial in factored form. Use synthetic division until you get a quadratic polynomial, then use factoring or the quadratic formula. So my p values, those are the factors of the last term, or of -3. So the numbers that go into -3 are 1, 3, positive, or those are both positive, and then -1, -3. So I'm just going to, with shorthand, put plus minus 1 and 3. The q values, so the numbers that go into the leading coefficient, those would be 1 and 2, positive and -1 and 2. So then if we make all the combinations where p is on top and q is on the bottom, that would be 1 over 1, 1 over 2. And then if I look at 3 as the numerator, that would be 3 over 1 and 3 over 2. So I'm matching up all the combinations with p as the numerator, q as the denominator. And then if I simplify these are 1, 3, 1/2, 3/2. So these are my candidates for my rational solutions. So just because it's on this list does not mean it's a solution. But if it's a solution, then it's going to have to be on this list. So I'm going to make some guesses, and then I'll talk about how to make a good guess. So a guess would be, let's pick 3. And I want to run through synthetic division on this. So I'm going to put the coefficients of my polynomial and run through a synthetic division. So I'm going to bring that down to 2. This will be 6, 11, 33, 29, 87, and 84. So I'm actually disappointed because I wanted this to be a 0. If I got a 0 remainder, then that would mean that 3 is a solution, but it's not. So now I'm going to make a good guess, and I'm going to make a good guess of 1, and I'll talk about how I made that. And I'm going to run through the synthetic division with that. So 2, 2 and 7, 7 and 3, 3, and I get 0. So that's good, because if we get a remainder of 0, that means that the number inside the box, or the one that we're using with the synthetic division, is a solution. So I can put 1 now officially as a solution. So they want us to use synthetic division until we get a quadratic, and then use factoring or the quadratic formula. So I want to, now that I've reduced this to a quadratic, because this is 2x squared plus 7x plus 3, I want to solve this. So I'm going to do that by factoring. So 2x squared plus 7x plus 3, and if I use the AC grouping method, AC and B, AC is 6, B is 7, so 1 and 6 multiply to be 6 and add to be 7. So that tells me how to split up my middle term. So that's going to be 2x squared plus x plus 6x plus 3. Then I want to factor by grouping. So x, 2x plus 1 plus 3, 2x plus 1, and then finish the factor by grouping. So my two other solutions would be x is equal to -1/2 and x is equal to -3. And you'll notice that those two numbers were on our list. So that is good. For the factored form, we already have most of the factored form because we've been factoring. We solved this by factoring. So I'm going to put that here. The only other thing that we're missing is the factored form of the 1, because we already have the -1/2 and the -3. So to get 1, that would have been an x minus 1. And let me put the p of x. There we go. Now a couple things before I talk about how to make a good guess. With the 2x plus 1, make sure that you don't put x plus 1/2. Because x plus 1/2 will get you the same number here. It won't get you the same polynomial when you redistribute it. So answers that are fractions, make sure you put it in this form, 2x plus 1, and not x plus 1/2, because it won't work if you try to redistribute it back to the original polynomial. Okay, so let me back up and then talk about how I made this good guess of 1 here. I kind of half cheated and I graphed the polynomial. And the graph looks like this. And you'll remember from the previous questions that your zeros, your solutions, these are the same thing as your x-intercepts. So if you use the the zero command on the calculator, then you can actually calculate where these cross. So I want to enter in my polynomial into y1 and then graph it and then press second calc or second trace, and then in the calculate menu I want to select number 2, which is the 0 command, and then I need to select somewhere to the left and press enter, somewhere to the right and press enter. So this is the interval in which my calculator is going to search, and then make a guess and press enter, and the 0 is the point 1, 0. So here this was x is equal to 1. Now this is kind of a very subtle thing, because I don't mind if you use the calculator to make a good guess. So I don't care if you use the calculator here to make a good guess. But I still want you to do the synthetic division and then the factoring or quadratic formula. So the reason for that is because like we'll be coming to some where you won't just be able to use the calculator. So it's kind of nice to use the calculator to confirm it and to make good guesses, but we'll be coming to some where it actually won't be able to help us. So that's why we're doing it. Plus, we're trying to use this process of synthetic division, not of just finding where it crosses the axis. But the reason why I do want you to use this to make good guesses and not just totally not use the calculator is because sometimes you'll have, I don't know, 36 different candidates, and that's kind of a waste of your time to be trying 36 different tries when you can just use the calculator to make good guesses. So again, long story short, you can use the calculator to make good guesses by finding out where the x-intercepts are, but you still must show the synthetic division and then the factoring or quadratic formula. Not only because we're just practicing this method, but also because on future problems the graph will not be able to help us on everything.